Good afternoon. This is Nuclear Plant Components. And today we're going to talk about steam traps. Well, first, we're going to talk about some properties of steam, and define some terms, etc. So, steam is a phase of water. Water is used in, we'll say, industrial, thermodynamic cycles, primarily because of its abundance and heat capacity properties. So steam is water in vapor form. Power generation, just like nuclear plants, uses water as standard working fluid and for heat removal. Due to steam's high heat capacity, a relatively small amount of steam can store and transport a large amount of thermal energy. So, substances in nature exist in either solid or fluid form. Solids have definite volume and shape. Fluids, they flow and have no fixed shape. Fluids include liquids, vapors, and gases. So let's get down to some steam terms or steam terminology. And this is for any fluids. So we have intensive versus extensive properties. Intensive is independent of the mass that is present. For example, pressure, temperature, and density. Extensive properties are a function of the mass present. For example, volume and mass. And when a property is described on a per mass basis, then the property is termed, or we should say is preceded the word specific. So when you see specific, as in specific volume, for example, specific volume is volume per unit mass. And for example, say specific internal energy is internal energy per unit mass. So let's take an example of phase change. So say we have water in a cylinder and it's under constant pressure. If the initial temperature, we'll call it T sub I, is say 60 degrees Fahrenheit, and we'll say the pressure is constant, and we'll say 14.7 psi absolute. And then say we then increase the temperature. By adding heat. We'll say to the water. So we set under constant pressure, we're going to add heat to the water in this cylinder. the temperature will increase. Once that temperature reaches 212 degrees Fahrenheit, this is what we call boiling point. And this is a change in phase. Some of the liquid becomes vapor. So once all the liquid has become vapor, any additional heat added will increase the temperature. So once it gets to that phase, say as heat is added, more and more liquid is being converted to vapor without an increase in temperature. So to restate that, once we reach the boiling point, the liquid is being converted to vapor, and the heat that was being added to increase the temperature is now just converting all the liquid to vapor with no temperature increase. But once all the liquid has become vapor, then the temperature will begin to increase again. So let's define some more terms. Saturation is a condition in which a mixture, vapor and liquid, can exist together at a given temperature and pressure. Therefore, saturation temperature is the temperature at which vaporization, in the case of water, boiling, starts to occur at a given pressure. Likewise, saturation pressure is the pressure at which vaporization starts to occur at a given temperature. So the relationship between saturation pressure and saturation temperature, at a higher pressure, then you will need a higher temperature to achieve saturation. And for water, the saturation pressure for water at 212 degrees Fahrenheit is 14.7 psi. And the saturation temperature for water at 14.7 psi absolute is 212 degrees Fahrenheit. So if the pressure was higher, let's just say 25 or 50 psi, then we would need a higher temperature to achieve saturation. So as pressure increases, you need higher temperature to achieve saturation. So let's uh, find some more terms that we use in our study of steam. Quality is the ratio of the mass of steam to the mass a steam water mixture. So quality is usually abbreviated by X, mass of steam over mass of steam plus water, or usually condensate. Moisture content the ratio of mass of liquid to total mass of liquid and vapor. So moisture content M is mass of liquid over mass of, say, vapor plus liquid. We define superheated as vapor at temperature greater than its saturation temperature. Gases are superheated vapors. So let's move on then to our study of steam traps. So the purpose of the steam system is to provide high quality steam at required temperatures and pressures and flow rates to the systems and components. We've defined the word, or we mentioned the word condensation earlier. So condensation is the process by which a vapor gives up its latent heat of vaporization and becomes a liquid. Carryover is the water that accompanies steam exiting a steam generator. Water hammer is the physical shock to components or systems caused by the impact of a high velocity fluid or pressure wave. Water hammer is usually accompanied by loud noises such as banging. So in a steam system, it is not unusual for some of the steam to condense. So condensation occurs when the steam experiences certain temperatures and pressures. So after forming, condensate flows to the nearest low point in the system. Steam traps are used to remove condensate from steam lines. So steam traps collects and remove condensate from steam lines without allowing the steam to escape. Steam traps are designed to rid the steam piping of condensate during normal operations and to prevent water hammer, erosion, and corrosion. Steam traps must also be able to remove air and other non-condensable gases from the piping during initial startup of the steam system. So generally speaking, a steam trap consists of a valve and a device that causes the valve to open and close. Typically, steam traps are located at low points in the steam lines. Ball float steam trap. So the discharge valve of this trap is connected to the float such that the valve opens when the float rises. The valve closes when the float lowers. So this is the float right here. And normal operation, condensate and steam enter into the chamber. As the level rises, the float rises, causes the valve to open, and the condensate is blown out of the trap. It works sort of like the float ball is in your toilet bowl or your toilet tank. Pretty simple operation. Once the level goes down, the float goes down, and the valve closes. Bucket steam trap. So as condensate enters, we'll say the trap body, the bucket begins to float. The bucket. The valve operates such that when the bucket rises, the valve closes. When the bucket sinks, the valve opens. So as the condensate flows into the body of the trap, the bucket begins to float, which keeps the valve closed. Eventually, the level of condensate builds up to the point that it begins to spill into the bucket. As it continues to fill the bucket, eventually the weight causes the bucket to sink. This opens the valve Then the steam pressure forces the condensate inside the bucket to drain. This is the discharge valve path up out this way. As the bucket empties, the bucket floats back down and the valve closes, which prevents the steam from escaping. So as the bucket rises, the valve closes. When the bucket sinks, the valve opens. The condensate entering the bucket causes the bucket to get heavier, which causes the bucket to sink and the valve to open. So this type of steam trap, bellows type, consists of a bellows and a volatile let me say it a little bit better. Consists of a bellows so that contains a volatile liquid and valve arrangement. So the bellows is filled with the volatile liquid. It's the bellows. The volatile liquid which means it's the best way to explain it is we'll say vaporizes easily. That's the best way to say it. So the volatile liquid is very sensitive to temperature changes. Which means it expands and contracts with temperature changes. And this expansion and contraction operates the valve. So in this image on the left side, this is where it's cooled, which causes the volatile liquid to contract. On the right side, it's hot, causing the volatile liquid to expand. As you can see here, close, open. So the cooler condensate causes the volatile liquid to contract. Valve is open. Hotter steam causes the bellows to expand. Valve is closed. So this is how the volatile liquid controls the valve. As hot steam enters the body of the trap, the volatile liquid absorbs that heat and expands. As the volatile liquid expands, the bellow expands, the valve closes, like we said. As the cooler condensate enters the trap, the volatile liquid cools and the bellows contract, allowing the valve to open and condensate to escape. Impulse steam traps, they pass steam and condensate through a strainer before entering the trap. The impulse type is dependent on the principle that hot water under pressure tends to flash to steam when the pressure is reduced. Which makes sense to what we said earlier. We said as your pressure rises, the temperature needed for a fluid to become saturated increases. So if your fluid is already at a high temperature, at a high pressure, and you reduce the pressure, then there's a higher likelihood, tendency, that fluid will vaporize. Pressure is keeping the fluid in a liquid form. Reduce the pressure, in this case, it will flash into the vapor form or steam. The only moving part in an impulse steam trap, is the disc. Some advantages of impulse steam traps. They have high condensate handling capacity for their size. They work over a wide range of steam pressures. Can be used on high pressure and superheated steam. Some disadvantages: they are easily affected by any dirt or debris which enters the trap body. Impulse steam traps can pulsate on light load causing noise water hammer, and even mechanical damage to the valve itself. Steam trap failures. Farm materials can collect of the trap, or trap components may corrode. Either one of these can cause a component to fail. You have stuck open discharge valve. This is indicated by steam blowing out of an in-service steam trap. This is a waste of steam. Stuck open discharge valves raise pressures and temperatures of drain systems downstream of the trap. Additionally, loss of steam pressure will reduce the efficiency of steam plant components and the overall efficiency of the plant. You have stuck closed discharge valve. This is less common and harder to detect. It is indicated by a lack of condensate in the drain line of an in-service steam trap. Steam line warm up. Steam lines are warmed slowly by opening a small bypass valve around the large pressure isolation or pressure control valves. This pressurizes the system slowly, which minimizes thermal stress on the system. By raising the temperature slowly. During this warm-up, excessive condensate is removed from the system by opening manual drain valves. This reduces wear on the steam traps. Steam traps are designed to remove the condensate that accumulates during normal system operation it would take steam traps too long to remove the large amount of condensate present during startup. To prevent this, steam lines are blown down through the steam trap blowdown valves or bypass valves during startup. The valves are open until all condensate is removed and a steady stream of clean, dry steam is discharging through the line. The valves are then shut and the steam traps are placed on line to remove the small amount of condensate produced during normal operation. Safety precautions. Always wear gloves. When operating steam valves. Steam valves should never open rapidly. They should be initially cracked open to allow pressure to slowly equalize across the valve. This prevents unnecessary shock to the system. Always be on alert for steam leakage. If there is a leak, take appropriate actions to isolate the steam ensure valve lineups are correct. Keep the rate of temperature change to a minimum to minimize stress to the system. Additionally, do not do rapid pressurizations. Solely pressurize systems and components to minimize stress on the system. Remove all collected condensate. As condensate can cause water hammer and uneven heating. Okay, so this concludes our study of steam traps. Please email me if you have any questions. Have a safe day.